So I talk about what the determinant is and how to find it in other videos, but I figured I should make one that's entirely focused on the determinant. So to find the determinant of a 2 by 2 matrix, which is the easiest type of matrix you can have here, you're going to multiply A times D and subtract C times B. So here we have the two parallel lines on either side of the symbol for the matrix. So here we have two parallel lines on either side of the letter denoting the matrix, and this just means find the determinant. So again, we multiply 3 by 8, which is A times D. 3 times 8 is 24. Subtract 4 times 2, which is 8. 24 minus 8 is equal to 16. So 16 is our determinant. You should only be coming up with one number. You shouldn't be coming up with a new matrix. Now it gets a bit harder with a 3 by 3 or 4 by 4 matrix. We do something called cofactor expansion. So here we have our matrix. It's just denoted with variables, so A11, A12, and so on. The first thing you're going to do is take your first number of your first row, first column, and you're going to multiply that by its matrix of minors. So you're going to cross out this entire row, cross out this entire column, and what you're left with are 4 numbers, and you're going to find the 2 by 2 determinant of these 4 numbers and multiply it by this number here. So that's denoted here. We have A11 multiplied by the determinant, so again the parallel lines are here, of A22, A23, A32, and A33. Now it's important to see this. You're going to subtract the next number. So it's plus, minus, plus, and if you have like a 5 by 5 matrix, it's going to be plus, minus, plus, minus, plus. Now for the next one, we take A12, cross out its entire column, its entire row, and find the determinant of the 4 leftover numbers. Same thing with A13, cross out its column, cross out its row, find the determinant of the 4 leftover numbers. Hopefully it'll be easier with an example. So we have the matrix here, 1, 2, 3, 5, 1, 2, 1, 3, 4. We are going to look at this blue right here. We're going to cross out this entire row, this entire column, this entire row, and what numbers are we left with? What numbers are not covered in blue? Well, we have 1, 2, 3, 4. So we're going to do 1, the number that's at the junction of the blue, multiplied by the determinant of those that are not colored in blue. So 1, 2, 3, 4. Now we're going to subtract 2, which is at the junction of these two purples, multiplied by the determinant of everything that is not colored in purple. So 5, 2, 1, 4. Now we're going to add, so plus, minus, plus, 3 times the determinant of what is not colored in yellow. So 5, 1, 1, 3. The determinant of this is 1 times 4 minus 3 times 2, which is 4 minus 6. Here we have, so 4 minus 6 is negative 2. And then we have 5 times 4, which is 20, minus 2, which is 18. We have that here. Then we have 5 times 3, which is 15, minus 1, which is 14. So 1 times negative 2 minus 2 times 18 plus 3 times 14 is equal to 4. 4 is our determinant of this 3 by 3 matrix. Now it's getting a lot harder to do. Not necessarily harder, but just like a lot longer. So there's also another way you can do cofactor expansion. Instead of taking the top row and multiplying these by their matrices of minors, you can take the first column. So this is just going to be a little example of it. I prefer to take the top row, so that's what I'm going to do in the next example. But so here we take A12 and we multiply it by the matrix of everything that we don't cross out. So if we take A12, we cross out this whole column, this whole row, and we're left with A33, A34, A35, all of this 3 by 3 matrix here. So we have A12 multiplied by this matrix. Now again, we subtract the next one, so A33. We cross out its entire row and its entire column, and we're left with a 3 by 3 matrix again, just with different numbers. Now we add A42 times whatever is not crossed out, so cross out this row, cross out this column. Then we have A13, A14, A15, this row as well, and this, so it's written down here. Now again, we subtract A52 multiplied by whatever is not crossed out, so what's not in this row and what's not in this column. So this 3 by 3 matrix here. So let's do an example. We have this matrix here, 2, 0, 5, 1, 1, 2, 1, 3, 4, 5, 0, 1, 1, 2, 2, 0. If you have one row with a whole bunch of zeros, what you're going to want to do is put that row at the top. Hopefully you'll see why after we do this example. So I colored these again. I have 2, which is at the junction of these two blue lines. So I'm going to do 2 multiplied by whatever is not barred out. So 2 multiplied by the determinant of these 6 numbers, or these 9 numbers, this 3 by 3 matrix, minus 0 times whatever is not colored in pink. So 1, 1, 3, 4, 0, 1, 1, 2, 2. So plus minus plus 5 times the determinant of what is not crossed out, minus 1 times the determinant of what is not crossed out. Let's just go by this step by step. So this is just what I said. We have 2 multiplied by the determinant of everything that's not crossed out. Remember, these 2 parallel lines means the determinant. Minus 0 times this, plus 5 times this, minus 1 times this. So see here, we have 0 times something. That's going to be 0. So if I had like 3 zeros in my top row, this would be so easy. Because let's say 5 and 1 were zeros. Then I'd have 2 times the determinant of this, minus 0 times something, plus 0 times something, minus 0 times something. And all of these, I wouldn't even have to calculate it because I know 0 times anything is 0. Let's start with this first one. We have 2 multiplied by this 3 by 3 matrix. So how do we find the determinant of a 3 by 3 matrix? Well, we just saw that. So we're going to take the first number again, cross out this column and this row, and multiply 2 by the determinant of the 4 numbers that are left over. So 2 times the determinant of this 2 by 2 matrix is 2 times 0 times 0, which is 0, minus 2 times 1, which is 2. So it's 2 times negative 2. Now we have minus 1 times, we're going to cross out its column, cross out its row, 5, 1, 2, 0. What is the determinant of 5, 1, 2, 0? 5 times 0 is 0, minus 2 times 1, which is 2, which is negative 2. Now we have a last one, we have 3 times the determinant of what's not crossed out, which is 5, 0, 2, 2. 5 times 2 is 10, minus 2 times 0, which is 0, so we have 10. So 2 times negative 2 minus 1 times negative 2 plus 3 times 10 is 28. This is not the end. This is not the determinant of the whole 4 by 4 matrix. This is just the determinant of this here. So at the end, we're going to do 2 times 28 minus so on and so forth. We're going to see what we get for the next answers, for the next determinants. Now, like I said before, 0 times anything is 0. Super easy. We don't do anything at all. It's 0. So here again, we do the same thing. We have this 3 by 3 matrix, and we're just going to find the determinant of it. So we take 1, we cross out its column, cross out its row, and multiply it by what is left over, but the determinant of what's left over. So 1 times 5 times 0, which is 0, minus 2 times 1, which is 2, 1 times minus 2. Minus the next number, so 2, cross out its column, cross out its row, 4, 1, 1, 0. 4 times 0 is 0, minus 1 times 1 is 1, which is negative 1, so negative 2 times negative 1. And we add 3, cross out its column, cross out its row, determinant of 4, 5, 1, 2. 4 times 2 is 8. 8 minus 5 is 3. 3 times 3. So 1 times negative 2 minus 2 times negative 1 plus 3 times 3 is equal to 9. That is our determinant of just this portion. At the end, we're going to multiply it by 5. The last one we have is 1, 2, 1, 4, 5, 0, 1, 2, 2. So we take our first number, cross out its column, cross out its row. We're left with 5, 0, 2, 2. 5 times 2 is 10, minus 2 times 0, which is 0, so just 10, minus 2 times, we cross out its column, cross out its row, we're left with 4, 0, 1, 2. 4 times 2 is 8, 8 minus 0 times 1 is 0, so 2 times 8, plus, this plus sign, 1 times, cross out its column, cross out its row, determinant 4, 5, 1, 2. 4 times 2 is 8, 8 minus 5 is 3. So 1 times 10, 10 minus 16, plus 1 times 3 plus 3 is equal to negative 3. Now our last step is just to add them all up. So we have 2 times our result here, which is 28. So 2 times 28 minus 0 plus 5 times 9 minus 1 times negative 3. Because these are all of the answers that we got for these 4 matrices. And our determinant of the entire thing is 104. So the last thing we're going to talk about in this video is Sarrus rule. This is just an easy way of finding the determinant of a 3 by 3 matrix. So here we have 1, 2, 3, 5, 2, 3, 0, 1, 2. And what we're going to do is we're going to expand it. So it's as though we're writing 2 of the exact same matrices beside each other, but instead of fully writing it, we're just going to write the first 2 columns. So here we have 1, 2, 3, and just like if we were rewriting it, we do 1, 2. Now 5, 2, 3, 5, 2, 0, 1, 2, 0, 1. We're going to start at the top left and draw a diagonal line all the way down to the bottom, like so. Move over 1, draw another diagonal line. Move over 1 again, and draw a diagonal line. Same thing for the bottom left. We draw a diagonal line up, and up, and up. So let's take this first bluish green diagonal line. We're going to multiply every single number on that diagonal together. So 0 times 2 times 3 is 0. Next for this one, it's 1 times 3 times 1, which is 3. 2 times 5 times 2, 10 times 2 is 20. Now we're going to add them all up, so 0 plus 3 plus 20 is 23. Now same thing for the purple, 1 times 2 is 4, 2 times 3 times 0 is 0, 3 times 5 times 1 is 15, add them up together, we have 19. Last step, we're just going to take the bottom number, subtract it with the top number, so 19 minus 23 is equal to negative 24, and that is it. So we've already found the determinant of this 3 by 3 matrix.